Hi Year 11, so we're going to start this term with a bivariate analysis. So it's kind of the next step on from the statistics we've already done. So bivariate analysis is concerned with the relationship between pairs of variables in a data set. So when we've got two bits of data and trying to find out if there's a relationship between them. So to do this, we'll often draw scatter diagrams. And so scatter diagrams are used to investigate the possible relationship between two variables, and we call that relationship their correlation. And a correlation exists when a change in x corresponds to a change in y. So if you see here, we've got some scatter plots. And the first one, we're going to say that has a positive correlation because just like a gradient line, it goes upwards, so it's positive correlation. The second one's a negative correlation because it's going downwards. And the last one's got no correlation because if you look at that, you can't say if it's positive or negative. Now, another way we describe scatter plots is by saying they're strong, moderate, or weak. So a strong positive means all the dots are pretty much almost on the same line. A moderate correlation means you can tell they're going upwards, but they're a little bit more spread out. And then a weak positive means they're still that correlation of it going upwards or downwards, but it's pretty weak and the dots are quite spread out. We can also class correlations as linear or non-linear. So here the first one's linear because you can tell the dots form a straight line. The second one, there's still a correlation, but it's in a kind of a circle shape, so it's just a non-linear correlation. We're only going to really focus on linear correlations. Now there's also something else called causation, which means a correlation between two data sets does not necessarily mean that a change in one causes a change in the other. Example 1. We want to represent this data on a scatter plot, then describe the correlation between x and y. So I have already done the scatter plot here for us. Okay, so you see there the points are plotted, the x and y are all plotted, and it says we want to describe the correlation. So with this correlation, we want to think, first of all, we're going to think, is it positive or negative? And then if we think it's strong, moderate, or weak. Now, obviously, it's open to interpretation, and if it wasn't an exam, they'd be pretty clear as to which one they were after. So with this one, we can see the dots are going upwards, which means that it's positive, and I would probably say this was quite strong because they're all quite close together with the dots. So this one I would say was a strong positive correlation. If you'd said a moderate positive in this situation, you would also be correct. Now we can also measure correlation, and we do this using something called the Pearson product moment correlation coefficient, which is represented by the letter R. And it's a measure of the correlation strength between two variables. It is commonly used as a measure of the strength of the linear correlation. Now be careful, don't get this confused with R squared that you may have done in bio or sports science. They're different. We only look at the R, we don't look at R squared. And when we're interpreting the R value, if the R value is between 0 and 0.25, it's very weak. 0.25 and 0.5 weak. 0.5 to 0.75 moderate, and 0.75 to 1 is strong. Now, if the R value is positive, it means it's a positive correlation. If the R value is negative, obviously it's a negative correlation, but we would still use this same language. So this second example, we've got a school basketball coach kept a record of the number of games played and the number of points scored for 7 players. Use Pearson's correlation coefficient to determine the strength of the correlation between x and y. So we're going to do this on your GDC. There is a formula that you can use to solve it. In an exam situation, they only want you to use the GDC to do this. The reason you may end up doing it with by hand is if you decide to do a statistics IA for your maths next year. So what I'm going to do now is we are going to go over to my GDC and I will show you how to do this on there. Okay, so on your GDC, from the main menu, you want to go to the list and spreadsheet function because we're going to enter that data from that table into the spreadsheet. So just click your spreadsheets. Now, I've actually already inputted the data just to save time. So put the first column in your spreadsheet and the second column is as well. And make sure your data, there is the same amount of data for each one. Otherwise you made a mistake and just go double check. Now in your calculator, to calculate the R value, it's really simple. You're going to go to your menu. You're then going to click Statistics. You're going to go to Stat Calculations and then Linear Regression, so the third one down. Click on that one, and now we're going to input our information. So our X data is in column A, our Y data is in column B, and so remember, to make sure it's a column, you need the square brackets. So you're going to press Control and the open bracket sign on your calculator, and you'll get square brackets. Leave the rest and then scroll down and make sure your answer is going to be in not A or B basically. So I'm going to say in C, so it's going to be the next column over. Click OK, and it calculates information for you. So the regression equation we're going to do next lesson, but for your R value, if you scroll down here, you have MB, R squared, and then you will find you have R. So for this set of data, the correlation R value is 0.957068. Round it to 3 significant figures, so the 0.957, which means because it's high, it's close to 1. It is a strong correlation, and because it's positive, it means there is a strong positive correlation between these two variables. And that's how you work it out in your GDC. It's that simple. Put your data in and go to your linear regression in statistics, and it tells you your value there for you.